In this case, we're asked to consider x equals y squared plus 2y plus 2, and x equals negative y squared minus 2y plus 2. And it would be easy to get thrown off by the fact that x and y are switched, and now we have quadratics, but in terms of y and what's going on here. But you need to remember that math is indifferent to what variables you happen to choose. So in this case, I'm looking at this saying, alright, y is my input and x is my output. I'm not going to get bound up in that x must always be the input. So I can treat this like anything else. And when I think of it that way and don't get bound up to what the variables are, that this choice for the original equation is no different than this choice. On the left, the input variable is y, the output is x. On the right, the input variable is x, the output is y. Their graphs will be the same, right? So if we stick with the notation of the problem, all this means graphically is that my y-axis is my horizontal, my input if we want to keep it the same. My x values are my outputs, the traditional y-axis. And so when I graph this parabola, it's going to look something like this for the first one. And x equals negative y squared minus 2y plus 2 will look something like that. And so what we're being asked for is what is the area here, which means I need to know this point and that point, their points of intersection. So go ahead and find the points of intersection. If you've done this correctly, you'll note that my drawing is inaccurate, but the points of intersection are supposed to be 0, 2, so that graph is wrong there, but we're not going to get bound up in the picture. And this point of intersection is negative 2, 2, which means that this area runs from negative 2 to 0. So we will be integrating from negative 2 to 0. And again, it's always the upper curve minus the lower curve. So in this case, the upper curve is negative y squared minus 2y plus 2. Let me just fix that. And I'm going to subtract the lower curve. And on that interval, the lower curve is y squared plus 2y plus 2. And since my variable is y, I'm going to integrate with respect to y. This cleans up pretty nicely. I'll do this one by hand, although you should also practice doing these by calculator. When I simplify this, this becomes, this should be 0, negative 2y squared minus 4y dy. When you integrate this, this will become negative 2/3 y cubed minus 2y squared from negative 2 to 0. And when you input the limits of integration, you will end up with an area of 8/3, because when you plug in 0, you will get 0 minus 0 minus, when you plug in negative 2, this will be 16/3 minus 8, and that simplifies down to 0 minus 16/3 minus 24/3. 16/3 minus 24/3 is negative 8/3, and 0 minus that is positive 8/3.